Welcome everyone, and thank you for being here today. I am excited to introduce our presentation on comprehensive management of medical gas systems. This is a crucial topic that covers the safety, storage, distribution, and regulation of medical gases in healthcare facilities. Over the course of this session, we will explore key aspects of managing these essential systems to ensure safety and efficiency. Let's get started. Today, we're focusing on the comprehensive management of medical gas systems, which is a critical aspect of healthcare infrastructure. Specifically, we'll look into the storage and delivery of medical gases, which are essential for patient care and safety. As we go through this chapter, Chapter 41, we'll highlight the key points that ensure these systems operate efficiently and reliably. Proper management of these gases involves not only understanding how they are stored, but also how they are delivered safely to the point of use. This chapter is designed to give you a thorough overview of best practices and safety protocols, connecting these concepts to the broader goal of maintaining a safe and effective healthcare environment. So, let's dive into the specifics of how we can optimize these systems for the best patient outcomes. Let's talk about the comprehensive management of medical gas systems, starting with gas cylinder safety. Ensuring safety here is crucial because cylinders contain high-pressure gases, which can pose significant hazards if not handled properly. That's why we rely on specific safety guidelines, which are developed by reputable organizations like the National Fire Protection Agency, or NFPA, and the Compressed Gas Association, known as CGA. These guidelines help us understand the best practices for storing, handling, and using gas cylinders safely. They cover everything from securing cylinders to prevent tips and falls, to proper labeling, and ensuring regulators and valves are in good condition. By following these recommended guidelines, we're not just complying with standards, we're actively protecting ourselves, our colleagues, and our patients. It all ties back to the overall goal of maintaining a safe and efficient medical gas system. Let's dive into the comprehensive management of medical gas systems, starting with gas cylinder safety. First, it's crucial to ensure proper storage and handling of cylinders to maintain safety at all times. This means organizing cylinders effectively so that full ones are kept separate from empty ones, which helps prevent confusion and mishandling. Next, we need to pay special attention to flammable gases. These should always be stored separately from gases that support combustion, reducing the risk of dangerous reactions. Temperature control is also vital. Cylinders should be stored away from sources of heat and kept below 125 degrees Fahrenheit to prevent pressure buildup or potential hazards. We must also consider combustible materials. Cylinders should be stored away from anything that could catch fire. Proper storage guidelines recommend using racks or chaining cylinders securely to the wall, which prevents them from falling or being knocked over. By following these safety principles, we not only protect everyone in the facility, but also ensure the integrity of our medical gas systems. Remember, safety is always a shared responsibility, and proper storage practices are a key part of that. Let's talk about the comprehensive management of medical gas systems, starting with gas cylinder safety. It's crucial to always keep the cylinder cap in place if the cylinder is not in use. This simple step helps protect the valve from damage and prevents accidental release of gas. Moving on to storage, especially for liquid oxygen containers, they should be kept in a cool, well-ventilated area. Proper ventilation is key to prevent the buildup of any gas leaks and to maintain a safe environment. Finally, the cylinder supply system enclosure must be carefully designed. It should be well ventilated and constructed from materials with at least a 1-hour fire-resistive rating. This ensures that, in the event of a fire, the enclosure provides enough protection and containment, safeguarding both staff and the equipment. All these points tie into our overall goal of ensuring safety and reliability in medical gas management. Proper handling, storage, and containment are essential for maintaining a safe environment for everyone involved. Now, let's talk about the comprehensive management of medical gas systems, starting with gas cylinder safety. Safety is the foundation, so it's crucial to follow all safety measures whenever we handle or transport cylinders. This helps prevent accidents and ensures everyone's well-being. Next, labeling requirements are essential. Always make sure that cylinders are properly labeled before transporting them. Using unlabeled cylinders can lead to dangerous situations, especially if the contents are unknown or mislabeled. Handling precautions are also vital. We should avoid dropping, dragging, or rolling cylinders, as these actions can cause damage or leaks. Gentle handling helps maintain the integrity of the cylinders and keeps everyone safe. Protection measures are equally important. Always protect cylinders from striking other cylinders or objects. This prevents damage and potential hazards that could arise from compromised cylinders. Finally, when it comes to transporting cylinders, use a cylinder cart equipped with a securing mechanism. This ensures the cylinders stay stable and secure during movement, reducing the risk of accidents. By paying close attention to these safety practices, we can effectively manage medical gas systems and maintain a safe environment for everyone involved. Let's go through some key safety practices for managing medical gas cylinders. First, when oxygen is in use, it's essential to post a no smoking sign. This simple step helps prevent any accidental ignition nearby. Next, always keep cylinders away from heat sources. Heat can increase pressure inside the cylinder and pose serious risks, so placing them in cool, well-ventilated areas is critical. It's equally important to never use damaged equipment. If you notice any issues with cylinder valves or regulators, do not attempt to use them until they've been repaired or replaced. Dirty or dusty valves can cause leaks or malfunctions, so before attaching a regulator, always crack open the cylinder valve slightly to clear out dust and dirt. Another vital point is to avoid flammable materials like oil or grease on regulators, cylinders, fittings, or valves. These substances can ignite if exposed to the gas or a spark. And finally, securing cylinders at the patient's bedside is crucial to prevent accidental falls or injuries. Properly securing these cylinders ensures safety both for staff and patients. By following these safety practices, we not only protect ourselves, but also ensure the safe delivery of care through proper management of medical gas systems. Let's talk about the comprehensive management of medical gas systems, starting with cylinder safety. It's absolutely critical to handle these cylinders with care because they are under high pressure. When dealing with high-pressure tanks, always open the valve slowly. This simple step can prevent dangerous pressure surges that might cause accidents or equipment damage. Now, moving on to MRI room safety. This is a very important point. Never, and I mean never, bring a steel medical gas cylinder into the MRI room. The powerful magnetic field in MRI environments can turn these cylinders into dangerous projectiles, posing serious safety risks. These safety practices are fundamental to ensuring both patient and staff safety, and they tie directly into the overall goal of maintaining a safe and effective medical gas system. Remember, careful handling and strict adherence to safety protocols protect everyone involved. Now, let's look at Slide 9, which focuses on the comprehensive management of medical gas systems, starting with bulk oxygen. The purpose of bulk oxygen is primarily to meet the large volumes required by big healthcare facilities. This is essential because hospitals often need a steady, reliable supply of oxygen for numerous patients and various medical applications. When we talk about the capacity of bulk oxygen storage, these systems are designed to hold at least 20,000 cubic feet of gas. That's a substantial amount, ensuring that the facility can operate smoothly without frequent interruptions. As for how bulk oxygen is stored, it can be in either gas or liquid form, but the most common method is liquid storage. Liquid oxygen allows for more compact storage and easier transportation, which is especially beneficial for large healthcare environments. Overall, managing bulk oxygen effectively is crucial for maintaining patient care and safety, ensuring that oxygen supply meets the demand without any hiccups. This fits into the broader picture of comprehensive medical gas system management, which aims to keep everything running efficiently and reliably. Let's talk about the comprehensive management of medical gas systems, starting with bulk oxygen. One of the key advantages is pressure management. By using bulk systems, we can eliminate the need for a bunch of separate pressure-reducing valves at each outlet, which simplifies the setup and reduces potential points of failure. Moving on to convenience and safety, bulk oxygen systems help us avoid the hassle and hazards associated with transporting and storing many individual cylinders. This not only makes our environment safer, but also more manageable. When it comes to reliability, bulk systems are less prone to interruptions. Since they're set up to supply a steady flow, we reduce the risk of running out unexpectedly, which is critical in medical settings. Cost-wise, although initial installation can be expensive, these systems tend to be much more economical over the long term. Fewer cylinders mean lower ongoing costs and less maintenance. Regarding low-pressure operation, bulk oxygen systems run at lower pressures, which enhances safety by minimizing the risk of leaks or ruptures. Finally, regulatory compliance is essential. Safety standards for bulk oxygen systems are established by the NFPA, and they are often reinforced or supplemented by local fire and building codes. Ensuring we meet these standards is crucial for a safe and compliant facility. Overall, integrating bulk oxygen systems aligns with our goal of creating safer, more reliable, and cost-effective medical gas management. Now, let's move on to slide 11, which focuses on the comprehensive management of medical gas systems, specifically the bulk oxygen gas supply systems. As you can see, there are three main types of systems, and today we'll hone in on the alternating supply system, also known as the cylinder manifold system. This system typically involves large cylinders, usually of H or K size, arranged in a series configuration. These cylinders are filled with compressed oxygen and connected together to provide a continuous supply. An important feature here is the automatic switching mechanism. When the pressure in the primary bank drops to a predetermined level, a control valve kicks in and automatically switches the supply over to the reserve bank. This automatic switch ensures an uninterrupted flow of oxygen, which is critical in medical settings. It minimizes the risk of supply disruption, maintaining safety and efficiency. Understanding these systems helps us appreciate how essential reliable oxygen supply is in patient care, and how these systems are designed to support that reliability seamlessly. Now, let's take a closer look at the comprehensive management of medical gas systems, starting with bulk oxygen gas supply systems. On this slide, you can see Figure 47, which illustrates a gas cylinder manifold system. This setup is crucial for ensuring a reliable and continuous oxygen supply in healthcare facilities. The key concept here is the alternating supply system. It consists of primary and reserve banks of cylinders, which work together to keep the system running smoothly. When the primary bank is in use, the reserve bank stands ready to take over automatically when the primary is depleted. This alternating process helps maintain an uninterrupted oxygen supply, which is vital for patient safety. The primary goal of these systems is to ensure a seamless transition between supply sources. This setup minimizes the risk of running out of oxygen and ensures that medical staff always have access to this essential gas. Connecting this to the overall theme, effective management of medical gas systems, including bulk oxygen supply, is fundamental to delivering safe and reliable patient care. It's all about ensuring continuous, safe, and efficient gas delivery in any healthcare setting. Now, let's talk about the comprehensive management of medical gas systems, focusing on bulk oxygen gas supply systems. These systems are essential because they store and supply oxygen in gaseous form for a variety of applications. You'll typically find them in medical facilities, industrial processes, and other settings where a reliable oxygen source is critical. These systems usually consist of several key components: storage tanks, pressure regulators, and distribution pipelines. Each part plays a vital role in ensuring the oxygen is stored safely and delivered efficiently to where it's needed. Safety is absolutely crucial when designing and operating these systems. Proper measures must be in place to prevent leaks and to handle the oxygen safely, because oxygen supports combustion and can pose risks if not managed correctly. Regular maintenance and continuous monitoring are also essential. This helps maintain the system's efficiency and, most importantly, ensures safety for both staff and patients. When managed properly, bulk oxygen supply systems provide a reliable, safe, and effective way to meet medical and industrial oxygen needs, tying back into our overall theme of ensuring safe and efficient medical gas management. Let's take a closer look at the comprehensive management of medical gas systems, starting with bulk oxygen gas supply systems. These systems are designed with three main components: the primary supply, the secondary supply, and the reserve supply. The idea here is to ensure an uninterrupted flow of oxygen. When the primary supply runs out due to demand, the system automatically switches over to the secondary supply without any interruption. Next, we have the cylinder supply system with reserve supply. This setup is most commonly used in large healthcare facilities because it offers economic benefits, safety, and convenience. A key advantage is that a small volume of liquid oxygen can produce a large amount of gaseous oxygen, which helps minimize space requirements, a crucial factor in busy hospital environments. Finally, there's the bulk gas system with reserve, which combines a bulk gas system with a cylinder reserve supply. It provides a reliable backup, ensuring continuous oxygen availability, especially in critical situations. Overall, there are three main types of bulk oxygen gas supply systems, each tailored to different needs and facility sizes. These systems are fundamental to maintaining a safe, efficient, and reliable oxygen supply in healthcare settings. Now, let's take a closer look at the comprehensive management of medical gas systems, starting with bulk oxygen gas supply systems. It's important to remember that liquid oxygen must be stored at temperatures below -118.6 degrees Celsius or -181.4 degrees Fahrenheit to stay in its liquid form. If it warms above this temperature, it will revert back to a gas, which is a critical point for safe storage and handling. Next, we have the role of the vaporizer. Essentially, the vaporizer warms the liquid oxygen, converting it into a gas that can be safely delivered to patients. This process ensures a steady and controlled flow of oxygen when needed. When it comes to pressure regulation, pressure-reducing valves are typically set around 50 psi. This helps maintain a safe and consistent pressure in the system, preventing any sudden surges that could be dangerous. Overall, understanding these components and their functions is key to ensuring a reliable and safe oxygen supply in any healthcare setting. Let's talk about the comprehensive management of medical gas systems, starting with bulk oxygen gas supply systems. These systems are essential for providing a reliable and continuous oxygen source. When it comes to storing liquid oxygen, it's crucial to understand that it must always be kept below -118.6 degrees Celsius or -181.4 degrees Fahrenheit. If it warms above this temperature, it will turn back into gas, which can be dangerous and disrupt the supply. This is where the vaporizer plays a vital role. The vaporizer heats the liquid oxygen, turning it into a gas that can be safely delivered to patients. Without this step, the liquid would remain stored but unusable as a gas. Now, regarding pressure regulation, it's important to maintain the correct pressure in the system. Typically, pressure-reducing valves are set at around 50 psi. This regulation ensures that the oxygen is delivered at a safe and consistent pressure, preventing any potential hazards or supply issues. Overall, managing these aspects properly ensures a safe, efficient, and reliable medical gas system, which is critical to patient care and safety. Now, let's move on to slide 17, which focuses on the comprehensive management of medical gas systems. As demand for liquid oxygen increases, we've seen a corresponding issue with the icing of heat exchange coils. This is a key point because it directly impacts the efficiency and safety of our oxygen supply. When these coils ice up, it can reduce heat transfer and compromise the system's performance. Next, we turn our attention to bulk oxygen gas supply systems. These systems are essential for ensuring a reliable, continuous supply of oxygen, especially in high-demand settings such as hospitals. Proper management of these systems includes regular monitoring and maintenance to prevent issues like icing and other operational challenges. Overall, effective management of medical gas systems is critical to maintaining safety, efficiency, and uninterrupted patient care. It's about understanding the equipment, recognizing potential problems early, and implementing proactive solutions. This way, we can ensure our systems support the overall quality of healthcare delivery. Let's talk about the comprehensive management of medical gas systems. First, it's important to remember that the NFPA sets strict standards for designing, constructing, placing, and using bulk oxygen systems. These standards are crucial for ensuring safety and reliability in medical settings. Now, a failure in the bulk oxygen supply can be life-threatening, especially for patients who depend on oxygen or gas-powered ventilatory support. That's why having backup systems in place is so vital. Facilities should have a secondary, smaller liquid oxygen tank or a gas manifold as a backup. This ensures that, in case of a primary system failure, patients can still receive the oxygen they need without interruption. Staff preparedness is also key. Staff members must be trained to quickly identify when the main system has failed and to move appropriate backup equipment to the bedside. This includes portable cylinders, bag mask resuscitators, and other emergency supplies. Being ready to bypass a failed system can make all the difference in critical situations. Overall, managing bulk oxygen systems effectively involves adhering to standards, having reliable backup options, and ensuring staff are prepared to respond swiftly. These measures are essential parts of a comprehensive approach to patient safety. Today, I want to talk about the comprehensive management of medical gas systems, focusing specifically on the distribution and regulation of these gases. This is a crucial part of ensuring safe and efficient delivery throughout the facility. First, let's discuss zone valves. You'll find these located throughout the system, and their primary purpose is safety and maintenance. They can be closed off when necessary, such as during maintenance or in the case of a fire, preventing gas flow in specific areas and helping contain any issues. Next, we have the main alarm system. This is a vital safety feature that warns staff of pressure drops or flow interruptions from the source. Prompt alerts ensure that any problems are addressed quickly, maintaining continuous and safe gas delivery. Moving on to gas pressure regulation. At the bulk storage locations, the pressure is reduced to a standard working pressure, which is typically around 50 psi. This regulation is essential because it ensures the gases are delivered at safe, manageable pressures for clinical use. The central piping system plays a key role as well. It's used to distribute the compressed gases from the source to all areas within the hospital, creating a reliable and organized network that supports various departments and patient needs. Finally, the primary function of these distribution systems is to deliver oxygen and air directly to the bedside at a workable, safe level. This ensures that medical staff can access the gases efficiently and safely, which is fundamental for providing quality care. In summary, these components, zone valves, alarm systems, pressure regulation, and central piping, all work together to ensure that medical gases are delivered safely, reliably, and effectively to support patient care across the entire facility. Now, let's take a closer look at the zone valves in a hospital piping system. These numbers you're seeing indicate the specific zone valves that control different areas within the hospital. Each zone valve plays a crucial role in managing the flow of medical gases, ensuring that the right amount reaches the right location. By properly managing these valves, we can maintain safety, efficiency, and reliability across the entire system. This is a key part of comprehensive management, as it allows for targeted control and quick response in case of maintenance or emergencies. Connecting this to our overall theme, effective zone valve management ensures that medical gases are delivered seamlessly and safely to support patient care. Let's take a closer look at the comprehensive management of medical gas systems, starting with the central piping system and zone valves. The central piping system is essentially the backbone that ensures the efficient distribution of medical gases or fluids throughout a building or facility. It's designed to make sure that gases reach their destinations reliably and safely. Zone valves are key components within this setup. They control the flow of gases to specific areas or zones, allowing for targeted delivery. This means we can turn on or off supplies to particular sections as needed, which greatly enhances operational efficiency. It also provides us with precise control over where and when gases are distributed. Depending on the system's needs, zone valves can be either automated or manually operated. Automation offers quick, reliable adjustments, especially in larger or more complex systems, while manual valves give straightforward control when automation isn't necessary. Finally, proper maintenance of both the central piping system and the zone valves is crucial. Regular checks and servicing help ensure these systems perform optimally over time and have a long service life. This all ties back to our goal of managing medical gas systems effectively, ensuring safety, reliability, and efficiency across the entire facility. Let's talk about the comprehensive management of medical gas systems, starting with safety-indexed connector systems. These are designed to make sure that the right gas goes to the right patient and the right equipment. One of the biggest risks in medical gas therapy is giving a patient the wrong gas, which can have serious consequences. That's why prevention is so important. The best way to avoid accidents is by carefully reading the cylinder or outlet label before connecting anything. Always double-check that you're using the correct gas. To help prevent misconnection errors, the industry has developed what we call indexed safety systems. These systems use unique physical configurations so that only compatible connections can be made, drastically reducing the chance of errors. Overall, these safety features are essential parts of managing medical gas systems effectively. They help us protect our patients and ensure that therapy is both safe and reliable. Remember, proper identification and the use of safety connector systems are key to preventing accidents in medical gas therapy. Let's take a closer look at comprehensive management of medical gas systems, focusing on safety connector systems. Ensuring the correct gas source is vital for patient safety and effective treatment. There are three main safety systems we use to prevent mix-ups. First, the American Standard Safety System, or ASSS, is designed to provide a unique connection for each gas type, reducing the risk of connecting the wrong gas line. Next, we have the Pin Index Safety System, or PIS. This system uses specific pin configurations on the gas cylinders and yoke connections, ensuring that only the correct cylinder can be attached to its corresponding outlet. Finally, there's the Diameter Index Safety System, or DISS. This method employs different thread sizes and configurations for each gas type, making it physically impossible to connect the wrong gas line. Together, these systems form a layered approach to safety, helping us manage medical gases reliably and securely. This is a key part of our overall strategy to ensure patient safety and system integrity. Now, let's look at slide 24, which focuses on the comprehensive management of medical gas systems, specifically the American Standard Safety System, or ASSS. The purpose of ASSS is to set clear standards for how the threaded high-pressure connections work between large cylinders, like F through H or K sizes, and their attachments. This is really important because it helps ensure that everything fits together properly and safely. One of the key safety features of ASSS is that it prevents accidental misconnections. That means it's designed so that you can't connect the wrong cylinder to the wrong device, which is crucial in a medical setting. By adhering to these standards, we reduce the risk of errors and enhance overall safety when managing these high-pressure systems. This ties into our overall theme of safety and quality management in medical gas systems, emphasizing how standards like ASSS help us maintain safe and reliable operations. Let's talk about the comprehensive management of medical gas systems, starting with the Pin Index Safety System, or PIS. This is a crucial safety feature designed to ensure that the correct gas connection is made and to prevent any accidental interchange of gases. It helps us avoid dangerous mistakes by making sure each gas has a unique connection point. Now, each gas has specific pin locations on the cylinder. For example, oxygen has pins at positions 2 and 5, while air uses positions 1 and 5. Heliox, which is a mixture of helium and oxygen, has different pin locations depending on its composition: 4 and 6 for the 80-20 mix, and 2 and 4 for the 70-30 mix. These unique pin configurations help us quickly identify and connect the right gas. The alignment mechanism is straightforward but critical. The pins and holes must line up perfectly to form a secure and correct connection. If the pins don't match the holes, the connection simply won't engage, preventing wrong gas connections. The primary purpose of PIS is for high-pressure connections, especially between small cylinders, those that are E-size or smaller, and their attachments. These cylinders typically have a yoke-type connection, which makes the system both safe and easy to use. Overall, PIS is an essential safety feature that integrates into our gas management system, helping us ensure patient safety by preventing incorrect gas administration. Now, let's talk about the comprehensive management of medical gas systems, starting with the Pin Index Safety System, or PIS. The main purpose of PIS is to ensure safe and correct connections between small cylinders, those that are E-size or smaller, and their attachments. These cylinders typically have a yoke-type connection, which is designed for stability and safety. The key to this system is the alignment mechanism. Pins on the cylinder and the corresponding holes in the attachment must align perfectly to form a secure connection. This precise fit helps prevent accidental misconnection, which could be dangerous. Another important aspect is that the locations of these pins are gas-specific. For example, oxygen cylinders have pins at positions 2 and 5, while air cylinders use positions 1 and 5. Heliox mixtures also have their designated pin positions, with 4 and 6 for the 80-20 blend and 2 and 4 for the 70-30 blend. The overall goal of these design features is to provide a safety net, making sure that connections are both safe and accurate. This system helps prevent errors, ensuring that the right gas is delivered to the right patient at the right pressure. It's a crucial part of the overall safety and precision in managing medical gas systems. Now, let's discuss the comprehensive management of medical gas systems, starting with the Pin Index Safety System, or PIS. The primary purpose of PIS is to ensure safe and accurate connections between small cylinders, typically E-size or smaller, and their attachments. These cylinders use a yoke-type connection, which requires precise alignment for safe operation. The alignment mechanism is critical here. The pins on the cylinder and the corresponding holes on the regulator or device must align perfectly. This prevents incorrect attachments and potential hazards. An important aspect of PIS is that the gas-specific locations of these pins vary depending on the type of gas. For example, oxygen cylinders have pins located at positions 2 and 5, whereas air cylinders use positions 1 and 5. Heliox mixtures also have designated pin positions: 4 and 6 for the 80-20 blend and 2 and 4 for the 70-30 blend. This system acts as a safety feature by physically preventing incorrect connections, thereby reducing the risk of gas mix-ups. Overall, PIS is a vital component in maintaining safety standards and ensuring the proper management of medical gas systems. Let's take a closer look at Figure 41.14, which shows the yoke connector. This component is really vital in our medical gas systems because it ensures a secure connection between the gas cylinder and the delivery system. The regulator inlet, for example, is specially designed to create a tight, leak-free fit, which is crucial for safety and efficiency. Now, one of the key safety features here is the pin-indexed safety system. This system helps prevent the accidental attachment of the wrong gas cylinder to the yoke. It uses a unique pattern of pins and corresponding holes, kind of like a lock and key, to make sure only the correct cylinder can connect. And it's specifically designed for cylinders ranging from size AA to E, which covers a wide spectrum of commonly used medical gases. So, in essence, this system not only secures the connection, but also safeguards against mismatching gases, which is essential for patient safety and effective treatment. This highlights how each component, like the yoke connector with its safety features, plays a critical role in the comprehensive management of medical gas systems, ensuring they function safely and reliably across different settings. Let's talk about the comprehensive management of medical gas systems, starting with the Diameter Index Safety System, or DISS. This system is specifically used for low-pressure gas connectors, typically operating below 200 psi. Its primary role is to ensure safety and proper connection, preventing accidental mismatches. You'll find DISS at the outlets of pressure-reducing valves that are attached directly to gas cylinders, which helps control the flow from the source. Additionally, DISS is used at station outlets of central piping systems, where it helps maintain system integrity. You'll also notice DISS at the inlets of various pneumatic equipment like blenders, flow meters, and ventilators. These connections are critical because they ensure that the right gas is delivered to each device, avoiding leaks or misconnection issues. Overall, DISS plays a vital role in the safe, reliable operation of medical gas delivery, connecting different parts of the system securely. This ensures that the entire system functions smoothly, which is essential for patient safety and effective treatment. Let's talk about the comprehensive management of medical gas systems, starting with the Diameter Index Safety System, or DISS. This system is designed to ensure safe and secure connections for gas delivery. One key component is the low-pressure gas connectors, which are used specifically for gases under 200 psi. These connectors help prevent accidental misconnection and ensure proper flow. Now, where do you find these DISS outlets? They are typically located in two main places. First, at the outlets of pressure-reducing valves that are attached to cylinders. This setup helps control the pressure right at the source. Second, you'll find them at station outlets within central piping systems, which distribute gases throughout the facility. Finally, DISS outlets are also found in applications involving pneumatic equipment. You'll see them at the inlets of devices like blenders, flow meters, ventilators, and other pneumatic tools. These standardized connections help maintain safety and compatibility across different equipment. Overall, understanding where and how these DISS components are used is crucial for ensuring the safe and effective management of medical gases in healthcare settings. Now, let's talk about the comprehensive management of medical gas systems, specifically focusing on regulating gas pressure and flow. No matter where the gas comes from, it's crucial that we control its pressure and flow to ensure safety and effective delivery. When we need to simply lower the gas pressure, we use a device called a reducing valve. This helps bring the pressure down to a safe, manageable level before the gas reaches the patient or the equipment. For controlling how much gas flows to a patient, we rely on flow meters. These allow us to precisely set and monitor the flow rate, making sure the patient receives the right amount of gas. And sometimes, we need to do both, manage the pressure and control the flow simultaneously. In those cases, a regulator is the ideal device, as it can handle both adjustments efficiently. Overall, understanding these components helps us ensure the safe and effective use of medical gases across different clinical settings. Now, let's talk about low-pressure gas flow meters, which are a key part of the comprehensive management of medical gas systems. The main purpose of flow meters is to allow us to set and control the rate of gas flow to the patient, ensuring they receive the right amount of oxygen or other medical gases. There are three main categories of flow meters used in respiratory care. First, we have the flow restrictor, which limits the flow by constricting the gas pathway. Next, the Borden gauge, which provides a visual indication of pressure in the system, helping us monitor gas delivery. And finally, the Thorpe tube, which is perhaps the most common type you'll see in practice. Each of these types plays a vital role in ensuring safe and accurate delivery of gases, which ties back into the overall goal of maintaining a safe, effective respiratory therapy environment. Understanding these different flow meters and how they work helps us optimize patient care and troubleshoot issues when they arise. Let's take a closer look at the comprehensive management of medical gas systems, starting with low-pressure gas flow meters. These devices are essential in measuring low-pressure gas flows accurately within medical settings. They are specifically used in systems where precise control of gas delivery is critical for patient safety and treatment effectiveness. The operational principle behind these flow meters is based on flow resistance. Essentially, they work by creating a resistance to the gas flow, which allows us to measure the flow rate based on how much the gas is impeded as it passes through the device. In terms of design and structure, these flow meters typically consist of a fixed orifice that's calibrated to deliver a specific flow at a constant pressure. This calibration ensures consistent and reliable measurements, which is vital in medical applications. Now, when we talk about flow restrictors, we're referring to the simplest and most cost-effective type of flow meter device. They might not have all the advanced features of more complex meters, but they are highly reliable for basic flow measurement needs. Overall, understanding these low-pressure flow meters and their components helps us appreciate how they fit into the broader management of medical gas systems, ensuring safety, efficiency, and precision in delivering respiratory gases to patients. Now, let's look at comprehensive management of medical gas systems, starting with low-pressure gas flow meters. These devices are essential for accurately measuring gas flow rates, but it's important to understand their limitations. One key point to remember is that their accuracy can be affected when pressure downstream of the orifice changes. This is because the flow measurement depends on pressure stability, so any variation can lead to less precise readings. However, despite this limitation, they are highly ideal for transport situations. Since they are not gravity-dependent, they work well when moving patients from one location to another, ensuring consistent gas delivery regardless of orientation. When it comes to how they operate, these flow meters use a fixed orifice but function under varying pressure conditions. This allows for a relatively simple design, but it also means that operators should be aware of the potential for inaccuracies if pressure conditions are not stable. Another important device in this setup is the Bourdon gauge, which is commonly used as a flow meter device. It's typically combined with an adjustable pressure-reducing valve, allowing for more precise control and measurement of gas flow. This combination helps maintain safe and effective gas delivery, especially in dynamic environments like patient transport. Overall, understanding these components and their limitations helps us ensure safe, effective management of medical gases across different clinical scenarios. Let's talk about low-pressure gas flow meters, specifically the Thorpe tube. Think of the Thorpe tube as a flow variable orifice device that helps us control and measure medical gas flow. It operates on the principle that increasing the size of the orifice allows more gas to flow through, which is essential for accurate delivery. Always remember, the Thorpe tube is attached to a 50 sig source, which provides the necessary pressure for proper function. The tube itself is tapered and transparent, so you can see the float inside. The float is suspended by the gas flow, and gravity acts on it as well. This balance helps us determine the flow rate. There are two types of Thorpe tubes, but in medical settings, we only use the pressure-compensated type. This design ensures consistent flow readings regardless of pressure fluctuations in the supply, which is critical for patient safety and effective treatment. So, in essence, the low-pressure gas flow meter, especially the pressure-compensated Thorpe tube, is a reliable way to measure and control medical gases, ensuring we deliver the right amount safely and accurately. On this slide, we're looking at the comprehensive management of medical gas systems, specifically focusing on low-pressure gas flow meters. These systems are designed to make oxygen delivery more efficient and easier for respiratory therapists to manage. The key idea here is integration, which simplifies the overall process. When a respiratory therapist selects the flow, they can directly connect the oxygen tubing to the system and to the patient. This hands-on control allows for precise management tailored to each patient's needs. It's a straightforward process that enhances safety and accuracy. One of the most significant benefits of these integrated systems is that they eliminate the need for multiple separate components like oxygen tanks, Borden gauge regulators, and the various keys or wrenches traditionally used. This simplification reduces clutter, minimizes the risk of errors, and saves valuable time during critical care. The grab-and-go system combined with the INTELLI OXDM is a prime example of this streamlined approach. It's designed for portability and quick access, ensuring that oxygen delivery is not only reliable, but also easy to deploy in any setting. Finally, the integrated oxygen cylinders themselves are a smart innovation. They combine the oxygen cylinder with a pressure regulator and an adjustable flow restrictor. This integration allows for precise control of oxygen flow directly from the cylinder, making the entire process more efficient and less prone to manual errors. Overall, these advancements are all about improving patient safety, simplifying workflow, and enhancing the effectiveness of oxygen therapy through smarter, integrated systems. Let's take a closer look at the comprehensive management of medical gas systems. On this slide, we see that integrated oxygen cylinders play a crucial role in ensuring reliable supply and efficient operation. One of the key features highlighted is the time optimization capability provided by the INTELLIO ADVANT system. This helps us save time and improve workflow, especially important in critical settings. For example, we can see timestamps showing how quickly the system responds, from 11:10 a.m. to 11:12 a.m., illustrating prompt action. Safety and storage are also vital. The oxygen cylinders are stored in designated areas, clearly marked with warnings like "Danger oxygen in use, no smoking or open flame," emphasizing safety precautions. The source shutoff valve and main alarm panel are critical control points to monitor and manage oxygen supply effectively. Moving on to oxygen distribution, the system connects various locations, from recovery rooms and surgical areas to patient rooms across different floors, including the basement. Cylinder banks and headers organize the cylinders efficiently, with high-pressure headers and valves ensuring safe and reliable delivery. The pressure management system maintains a constant pressure source, typically around 50 sig, through components like fixed orifices and pressure relief valves. These devices help regulate flow and prevent overpressurization. The line pressure regulator further ensures a steady supply. Looking at the oxygen cylinder components, we see essential parts such as vaporizers, which convert the stored liquid oxygen into gas, and pressure-reducing valves that control flow to the patient. Insulation and near-vacuum conditions help maintain system stability, while the ASSS connection provides a secure link within the system. Overall, this slide underscores how integrated, well-managed oxygen systems are designed to maximize safety, efficiency, and reliability, crucial elements in delivering quality patient care.